Hello and welcome to this discussion on human-robot interaction. Uh, I welcome you all to this discussion, and my name is Vinay Krishna Sharma. Let's Before starting, let me introduce myself. My name is Vinay Krishna Sharma, and I am a mechanical graduate from the Institute of Technology, Ranchi. I have done Masters in Master of Technology in Mechanical Engineering from Indian Institute of Technology, Dhanbad, which was previously Indian School of Mines, Dhanbad, and currently I am pursuing my PhD in Human Robot Interaction from Indian Institute of Science. I work in I3D lab at the Center for Product Design and Manufacturing in IISc Bangalore. I have qualified GATE multiple times. With God's grace, I have 2 patents and 3 research publications till now. And before joining my post-graduation and after my graduation, I have worked for Cognizant Technology Solutions as a programmer analyst for 2 years. And like just to share with you guys that I'm not a boring person at all. So with all my research and study, I'll have hobbies like I'll love playing football. So this picture is from an inter-IIT tournament in which we participated. I like reading, though I rarely get a chance to read except my research papers. But yeah, reading is one of my habits. And biking, I also love bikes, and I love to ride them around when I have time. So let's start with the discussion. So the contents for today's discussion are going to be in 2 parts. In the first part, we'll discuss applications and uses of robotics in various different sectors, as in industries and manufacturing, military, healthcare, education, space, underwater robotics, emergency response and disaster management, and we'll look at some other robots. And also, like, we'll discuss the timeline of robotics, the growth of robotics, how robotics came into being, and what is the state of art today, and how it's all started way back in 90s during the World War time. Also, like, the next part of the discussion will focus on human robot interaction. What is human robot interaction, and why does it came into being, and why it came as a separate subject out of robotics, machine learning, and AI, and with the advent of this new technology. So we'll be discussing what is human robot interaction, what are the robotic fundamentals, what are sensors and actuators, what are different interaction modalities which we'll be using to communicate to robots, what is computer vision, what is machine learning, and how to like program robots in Python and ROS, and use gazebo simulations to simulate a robot in a virtual environment. So without any further delay, let's get started, and here we go. So we'll first see the robots in the industries and manufacturing. So the biggest driver for this revolution of robotics, which started back in 1950s and 1960s, is the industries and manufacturing facilities, which demanded our engineers and scientists to devise such intelligent and precise machines which can work for like continuously in our factories. So here you can see most of us today are driving cars which are being manufactured by such series of robots, and obviously like some of us will be watching this video in mobile phones which are probably manufactured by or assembled by a robot like this one. And like we order from Alibaba, from Amazon, from Flipkart, so there is a high probability there's small warehouse robots like these will be managing and packaging our deliveries in a warehouse. So all these robots are highly accurate, very precise, and repeatability is none of their property. They can work for 24/7, and they do not get tired. They do not need breaks in between. They do not need food. All they need is just a constant power and like a good program running at the back end. And the one more use for these robots is they are programmable to adaptability. So unlike humans, they need not to adapt to a changing new environment. Like they do not take time to adjust to a new task. You can just directly program it from one task to another task, and they will just do it without any making a fuss about it. And on a long term, they are very cost effective and they are very safe. So think of a welding situation, a cutting situation, which can be hazardous to humans. We can use robots and big robotic arms there, where like there can be a risk to human life in manufacturing. Next, we will see robots in military. So one of the biggest believer in robotics is, after manufacturing and industries, is military and defense. So we the researchers have tried from long back in history to devise machines which can be used for bomb landmine diffusers, which can extract wounded soldiers, which can be used for surveillance, and of course which can be used for killing enemies, and uh, which can be deployed at the borders. So here you see there is a wheeled robot with an arm manipulator, which with cameras and other sensors on it, which can be used, which is helping this bomb defusal squad guy to in finding and defusing bombs. Here you see like couple of soldiers are using this flying robot, which is a quadcopter, which is also another form of robot, to uh, send it to an area, far off area, for the purpose of surveillance. So like instead of, so that they can avoid any conflict or any encounter with enemies. So so just to so these robots are their eyes in the sky. And on the top right there is a very small tank like robot, which is fitted with all sort of guns and grenade launchers and all other sensors, which can be used to immobilize or like kill your enemies. So this is also a very big area which is highly interested and supportive in the role of robots today. Next we see robots. What are the different robots in healthcare? So the type of robots that we see in healthcare are hospital robots for telenursing and telemedicine, surgical robots, care robots for elderly and rehabilitation, and exoskeletons for mobility and for mobility impaired people. So a very good example is this recent time of lockdown and due to coronavirus. So these big robots are performing tasks such as disinfecting the hospital facilities, providing deliveries, medicines, and communication to remote uh, patients. So on the left you can see there is a big robotic arm, a collection of robotic arms which are fitted with different surgical tools, and this robot on the left is operating this robot through an interface. So these kind of surgeries are very minimally invasive, means like they need not cut through the whole section of the body to operate something, but they're very small, very precise, and they can just make a small hole in the body and go enter from there and do their task, whatever the doctor needs, and the person can recover really soon. On the middle section, on the middle picture, you can see there is a patient lying in the bed, and there is a big robot on her side, in which the doctors, the nurses, and even the remote relatives can talk to the patient. This robot will remind the patient of taking her medicines on time. It also has a touch screen which the patient can operate to call for any help, or if she wants to talk to her parents, which can be in another city or in another country. And also like these robot is fitted with sensors which can be used to read all the monitors and take the parameters, check the vital signs of the patient. On the top right there is an exoskeleton which looks like this uh, mechanism, and this can help an mobility impaired person, or a person who is not physically capable of moving or physically capable of walking. It can support the lower structure or the back of that physically disabled person and help them walk. Okay, so robots like these are helping in healthcare also, in the form of care robots and other social robots. Now we see robots in education. So like with this recent advancement in technology, we are having robots entering our classrooms. So they are making one-to-one tutoring is possible. So as there is a high demand in number of teachers in schools, and also with the rising population, there are more number of the students per teacher. So we can remove this barrier by using robots as mentoring or tutoring support. They can enable especially able to attend the schools. So what it means is a physically disabled person who is not capable of going every day to school, instead of sending him to school, we can have a robot like this you see on left, which can go with a screen. With a screen, the robot can attend the school on behalf of the physically disabled student, and like the student can see the can see the live class and talk to his friends through live live video conferencing. And these robots provide a safe and neutral learning environment also. Like, so there are a lot of cases in bullying and students being feeling shy to attend classes. They're not responsive. So like, to make learning more fun and easy for students in school, in preschools and like middle schools also, robots are being deployed, so they can teach students in a fun way. On the top right, do you see a robot which is used for robotics and STEM education? The children learn to program robot and learn basic concepts like motors and actuators using a computer. On this left bottom, there is a robot which is teaching science concepts to a remotely located students in a village. So with this, like, a single teacher can handle multiple students at different locations. So one of the most uh, promising area where robotics is proving its worth is space. So like, it's very difficult to go in space, and it's not easy to survive in adverse conditions like that. So but still we are having remotely operated vehicles on Mars. So like, it's a robotic vehicle on the bottom left you can see, which is being operated by people on Earth, and the robot is on Mars, and you can collect samples, you can maneuver a vehicle there on the surface of Mars by sitting here on Earth. There is a remote manipulation system which you can see on the center. So it is a big robotic arm fitted with all the tools and sensors, which can be operated from inside a space shuttle. So even the space shuttle needs some kind of maintenance, and on the maintenance on which needs an astronaut to fly out of the spacecraft and go and check the fault himself. So instead of doing that, which is very risky for the astronaut, if you have seen the movie Gravity, and astronauts may like lose contact with the uh, space station or the space shuttle and get lost in the space. So they can use what they can do is they can use a robotic arm like this, which is fitted with all kind of tools, and they can operate this robotic arm from inside the space shuttle and do perform all kind of maintenance which they have to. On the right is a robonaut. So this robonaut is a complete humanoid robot, a human-like robot, which is capable of performing all the tasks which a human is able to do. So what NASA is planning is to, like, instead of sending humans and risking their lives to space, they are sending robonauts, like a humanoid robots like this. So this helps in like reducing the weight of the spacecraft, as they need not send any human. They need not to care for the oxygen supply. They need not care for the uh, food and waste disposal of the human astronauts. Instead, they can just send a robot which can work, and which can be operated, which can autonomously operate, which means like this robonaut can operate by itself, or you can operate this robot with the help of with the help of a system back in the Earth. Like, down in from Earth, you can operate you can operate the spacecraft and this with the help of this robonaut. So even underwater, even like deep down in the sea, we have robots there. So what type of robots do we have? Like, on the bottom left you can see there is a robotic fish which can be operated by a joystick like this, a gaming pad like this, and this can be used for deep sea explorations and deep sea uh, mining, observing corals and like the deep in the flora and fauna deep down under the sea. So, and it can take scientific samples, it can take pictures, it can go at the very shallow very deep trenches, and which are difficult and dangerous and dark for humans to go. On the middle, you see a robot, an underwater robotic arm, which is used for inspecting and performing maintenance activity of the underwater pipelines. So these can be oil pipelines, the internet grid or internet uh, cables. So they also get withered with time. So they need maintenance. So you can send these robotic arms, which can be mounted on an unmanned underwater vehicle like this on the right, and you can perform some manipulation there. Also, in case of some disasters, you can use such robots like for search and rescue. So this is on the top right. This is an underwater unmanned vehicle which is used for uh, exploring the deep sea, where the humans cannot go, where the human divers cannot go. So but you can send these unmanned air vehicles down there, and you can operate these from the shore, sitting on the shore with a computer. So next we'll see about some emergency response and disaster management robots. So like suppose there is a landslide or an earthquake, and there are people stuck under the debris. You can send robots like this on the top left, which can remove the debris and take out the survivors and the victims of the disaster, carry out the victims of the disaster. Or a robot on the right like this, which can carry out injured soldiers, injured persons, and uh, take them out from the disaster location to a safer place. So suppose in case of a forest fire or a geographically separated area where people need some kind of first aid or some other food deliveries or other deliveries, we can send these robotic quadcopters, or like these flying robots carrying packages from like from a which can fly over from a distance of like few kilometers to like 15 like 60 kilometers, and they can drop the package and come back. And even like they can take pictures of the route on the way to the destination, and which can be really helpful. So some other interesting robots are this. So on the left, you see here is the Sophia robot by Hanson Robotics. So this is the most talked about and the first completely autonomous robot in the human mankind. This, you must have seen her on different interviews on YouTube or in news channels. So she can talk, she can answer your questions, she can hold objects from her hand, like, and she can do all this autonomously. Then on this center, we have this robot called Atlas by Boston Dynamics, and it is the first parkour robot. It can walk, it can jump, it can even do backflips. You can search it online, and it's very amazing to see like what this robot can do. On top, we have this hexapod, which looks like a spider, but and it is inspired from a spider. On the right, we have this Boston Dynamics Spot, which is a robot dog, and it is capable of autonomously navigating through forests, for through cities, and even it can open doors. It can close doors. If you will kick him, it can like get back up, and it has all sorts of similarities to a real dog. So the biggest invention or the biggest use of robotics in today's world is self-driving cars. So here you see a self-driving car. It can drive. It can drive through a traffic road, and it can safely go from source to a different destination, while like taking all the turns by itself, detecting all the other cars on the roads by itself, like braking whenever required, avoiding any kind of an obstacle, or like avoiding all kinds of crashes. So this is also a wonder of technology in today's time we are seeing, and these are becoming very increasingly popular in coming times. So like we are not that future is not far where we will be calling an Uber or Ola or a taxi cab which will come without a driver, and we have to just sit there, read a newspaper, or just check out a story on Instagram, and we can just reach to our destination without worrying about the traffic on the road, or who is driving, or how good is the driver. So this is a complete history or a timeline of robotics, starting from 1941, when as Isaac Asimov first coined the term robot, moving on to the Turing test, which tests like what is whether a machine is capable of uh, whether the machine is intelligent or not. Then moving on to the Stanford robotic arm in 1969. Then like this is the first Sentry robot in 1985, which is like which could patrol for more than 14 hours and alert about anything unusual in a range of about 150-foot radius. Next up is like the most biggest achievement which I will consider is like when a computer beats a human at chess. So this is in the year 1997 when the Deep Blue beats Gary Kasparov. So like chess is a human developed game, and Gary Kasparov was the world champion for a long time before Deep Blue and computer algorithm which beats Gary Kasparov in the game. Like a computer beats human in a game which was invented by humans. And also like in 1997 we had our first RoboCup competition. So it's a soccer competition where a team of three robots play football or soccer against a team of three other robots. So it's very interesting to see where robotics was going way back in 1997. Next we had this DARPA's Centibots. So these are like these are the first iterations of warehouse robots, small which can work like as a team together to perform a bigger task. There are a group of small robots which we can use to work as a team, which can work as a team. Next is the in zone 10 we had the Robonaut, which we saw just few slides back, and in zone 10 we had 3D printing, so which totally revolutionized the process of designing and manufacturing and like realizing your ideas. And next in 2014 we had our first exoskeleton, and in 2010 we had the Google's DeepMind AlphaGo. So Go is considered to be the most difficult game the mankind has ever seen, and the Google DeepMind and algorithm was able to beat the world champion of Go in this game. So this is considered as one of the biggest achievements of artificial intelligence and robotics in these times. So as you can see, starting from 1941, 1939 and till like 2020, the robots and the technology keeps on improving and keeps on getting better and better. So a lot of research has been done in the field of how to design robots, how to like give shape to a robot, and what are the different mechanisms, what are the different algorithms I can to program a robot to do certain tasks and to implement a robot in different sectors. But as the technology advances, that day is not far when we'll be having a robot, like each of us will be having a robot at our home, which is helping us to carry out day-to-day tasks like cleaning our house, putting the utensils back in the rack, and drying our clothes and doing all sorts of household daily works. So so with this it becomes highly important to study like what are the different interactions, what are the different ways of communication with a robot. So nothing much has been done till now in order to study what are the best ways to communicate with a robot. So either just programming it using a keyboard is the best way, or just telling it, okay, I want this, please do that, please bring me a cup of water, or like I can just do my gestures, or whatnot. Like what are the different natural ways of interacting with the robot and communicating with the robot. So this gap introduced the subject of human robot interaction, which is the study dedicated to understanding, designing and evaluating robot systems for use by or with humans. So like this is the study of understanding and designing, evaluating robotic systems which are being used by humans, or which are designed for humans. So excuse me, this subject takes care of not only the designing part of the robots, but investigating and evaluating how good and how easy is to interact with the robot. So like these are the basic topics like which comes under the purview of human robot interaction. Like we need to know the robot fundamentals, what are the sensors and actuators, like a robot needs to sense any change in their environment, in their surroundings, and how can they manipulate their environment, and what are the different kinds of interaction modalities available for us, and what are the different kind of interaction modalities that we can evolve or we can develop in order to interact. And the computer vision, machine learning, localization, mapping, all these are the eyes and brains for a robot to see their surrounding, understand their surrounding, and then process the information that the robot sees in their surrounding and take a decision based on that. And Python, ROS, and Gazebo simulation provide a platform to write a program or tell your instructions to the robot and integrate all these different kind of sensors together and perform a robotic operation or design a robot in a simulated environment. So you need not create a physical robot every time you want to try something, but you can do what you can do is just simulate a robot in a virtual environment and try and test different strategies of interaction. So as you can feel, this human robot interaction is a mixture of different fields like engineering, scientists, and designers, and then like which takes in information in knowledge about technology, human behavior, and how the world works. So it's a majorly interdisciplinary field. So like next we will discuss one by one all these topics. So like what is the first, let's understand what is a robot. So robot is a programmable machine designed to perform a function or task with or without the aid of a human. Okay, so it's a machine and these are the components of a robot. So like a robot must be having a physical body. It needs to have a communication link which can be wired or wireless. It has different sensors. So sensors are the body parts and eyes and nose and ears of a robot, and actuators are the hands and legs of the robot, like by means of which it can a robot can manipulate the environment or change the environment, pick something, drop something, push a button. All these all these are possible because of actuators. So all the robots, as we have seen, comprise of just these 4 or 5 parts. Like all this structure, these components of robot is common to all the robots, whether it's an exoskeleton, whether it's a healthcare robot, whether it's an underwater robot, whether it is a flying robot. So these are the basic. This is the basic strategy on which any robot works. So sense, plan, and act. Sense what is there in the surrounding, plan what to do next, and how to do it, and act. Like execute your plan. Right. Next, we'll see what are sensors and actuators. Sensors are devices which measure the changes in the environment. So suppose I am filling my tank and there is a water level indicator which will tell me, okay, my tank is full now. So my water level meter or water level indicator is a kind of sensor which will tell me a change in environment. So filling, my tank was not filled before, but it is filled now. So this is a change in environment. Actuator are devices which manipulates the environment. So actuator is something which can manipulate the environment. So when my tank is full, I want to switch off the pump. So a motor will switch off the pump. So motor is an actuator and a water level meter is a sensor. So this is how sensor controller actuator loop works. So basically this is my physical system or my environment. A sensor will sense any change in the environment. It will send that information to the controller or the brain of the robot. Controller is the brain of the robot. It will make some sort of inference or interpret that data which is sent by my sensor, and it will take some decisions, and it will, based on those decisions, it will tell some actuator to perform some action on the physical system. On the right there is a picture of all, like not an exhaustive picture, but all kind of sensors that you can have. So we can have machine vision or ambient light sensors, or position, presence, proximity sensors, motion, velocity, displacement, temperature sensor, humidity, acoustic sound and vibration, chemical and gas, flow sensors, leaks and levels, force, load, torque sensors, electromagnetic sensors, acceleration and tilt sensors. Next we see what are the different kind of interaction modalities available. So interaction modalities are the ways in which a human communicates with a robot. So you can, in everyday life, you use a monitor, a mouse, a keyboard, now touch screen on your phone, or a joystick to control a robot. So all others are, you can use a headset, like VR headset you can use to interact with a robot, a controller like a gaming console you can use to interact with a robot, your gestures you can use like in Kinect, or your voice like Alexa, Siri, your OK Google, do this, do that. So the output we get from in form of a display or sound or even vibration like in controllers. On the top center, we have this brain-computer interface. So how it works is you just need to think what you want to do, and it will pick up signals from your brain, and it will make that robot do the task for you. On center below, we have this haptic glove, which lets you drive a car or fly a drone. So just you have to tilt your hand in certain directions, and it will follow your gestures and convert them into command for the robot. in recent times and with the advancement in technology, we have a new kind of interaction which is like eye gaze interaction. We can just use our eye gaze to interact with the robot with the computer screen. So you're looking from a position from A to B, can move a robot from position A to B, or your blink can activate a function, and your like double blink or triple blink can activate some certain other function. So computer vision is understanding and interpreting information from visual data. So computer vision basically means the eyes for a computer. Okay. So if I ask you to look here at the top left bottom and tell me what are all the fruits present in this plate, so you will use your eyes to see this plate, and you will process, like in a fraction of a second you will process, okay, these are the fruits which are present, right? So there is a bowl with orange, banana, peach, mandarin and apple. So same thing it is needed for a robot. So the input is the same image, but a sensing device can be a sensor, and interpreting device, so instead of brain it is a computer, and sensing device, so instead of my eyes I have all these sensors, cameras and light sensors, right? And I can do the processing and give me this, what are the things present in my plate. So like just in a fraction of second you were able to differentiate between all these colors. So oranges are orange, tomatoes are red, banana is like yellowish, and they have different textures, right? So if I have given you a black and white image of these foods, then you will be in trouble to figure out which fruit is what. So there are different underlying parts to your thinking which you did, like semantic and segmentation. You, based on the shape and size and texture of the fruit, you were able to find out, okay, and there is classification and localization. So you were able to tell the banana is on the top right of the plate, orange is at the bottom of the plate, and then there is object detection. So because you have seen these fruits before in your life somewhere, like this is a banana, this is a peach, this is an orange, you were able to detect, okay, these are the objects present in my plate. So if you have never seen a banana before and nobody has ever told you what a banana looks like, then you will not be able to detect this banana, right? Same is with the instant segmentation. So like with these features and textures, you are able to differentiate between all these fruits sharply. So same is the case with a robot. So the robot doesn't have a brain and understanding like a human, so we need to tell it and train it specifically based on what it sees in the image. Okay, so on the top right you can see this is this is a kind of a screenshot from a from a autonomous vehicle. So the autonomous vehicle need to take care of all this information just based on a picture. So it needs to detect all the cars or all the kind of vehicles present, car, truck or bus or a motorcycle. So what are the different people, it needs to identify all the people present on the road, what is the traffic signal it is saying. So it needs to take care of all this on itself. So there is no like human brain sitting there and telling, okay, don't go forward now, take a right, take a left, there is a car in front of you, there is a person right behind, right? So all this kind of activities is being taken care of by the computer vision. Next up is machine learning. So machine learning deals with making robots learn to perform tasks accurately without the need to program them for the task. So just as we learn from examples, enable robots to learn from a task examples in previous experiences. So like a child, so when a child is small, we used to like show him pictures. Okay, it's a cat, this is a dog, that's an aeroplane, that's a tub, that's a mug. So the child learns from examples. There is no inherent knowledge by birth in the child about what are all these objects, what are they used for. So the child learns from his experiences and from what we all teach him or talk to him or what all images we show him. So similarly, so machine learning is the field of making the algorithm smarter, making the robot smarter, so that it can learn from the experiences itself. So instead of writing the code like go for an autonomous car, go right, go left, every time it encounters something, I should make it smart enough to see, okay, the red light means to stop, the green light means to go, and if there is an object in front of you which is, so stop, take a turn and then avoid the object. So all this I need to make the robot or the car learn by itself. So there are three types of machine learning: supervised, unsupervised, and reinforcement learning. Supervised learning is learning from labeled examples. So learning from labeled examples means I'll show you pick 10 pictures of cat and 10 pictures of dog, and if I ask you to separate them, okay, so you can do that. So because you already know this is a cat, this is a dog, so all the examples are labeled. You just need to figure out based on your experience, okay, this is a cat, this is a dog, and separate them. Unsupervised learning is there is no labeled data, so you don't know which is what. So based on some underlying patterns of the data, you need to figure out what is uh, how it is the data is clustered, how the data is classified. So one example can be, if I give you colored triangles and colored circles and ask you to separate them based on some similarity. So one similarity that you can take is the shape. Okay, triangles are different, circles are different, so you can separate them. And one similarity can be the color. So without even telling you what property to use to group them into different clusters, you used some kind of underlying feature. Okay, the shape of a triangle is different from a shape of a circle, so you use that to separate or classify or cluster them together. Reinforcement learning. So reinforcement learning is like what we do in most of the time, like learning from our mistakes. So like a child, if you want to make him do his homework, so you let him watch his favorite cartoon every time he completes his homework before the show time, and you don't let him watch his favorite cartoon if he doesn't complete his homework. So with some time he will learn, okay, completing my homework on time results allows me to watch my cartoon, and not completing my homework does not allow me to watch cartoon. In a similar way, if we program a robot in such a way, like I don't tell him so what the task of the robot is. I will just assign some rewards, some and punishments. Suppose the task of the robot is to same as switch off the water tap when the bucket is full of water. Okay, so I assign them some numbers. So when the bucket is almost full and the robot closes the closes the water tap, and I'll give it a score of 10. Otherwise, if the water is like overflowing, I give it a score of -5 and let it run many iterations of itself doing the task. So with this score of 10 and -5, 10 and plus 10, -5, plus 10, -5, and with this repeated learning, it will be able to understand, okay, so this is a task I need to perform. I need to close it when the water gets full, and not the other way around. So you can see this is an agent, this can be a robot, and it takes state and action on the environment and gets reward and new state from the environment, right? So state is okay, closing. So state is like water is filling or the bucket is full or not. The action can be like close the tap or don't close the tap. So reward is +10. A new state is like you got -5. That means water is overflowing. Or if you get +10, that means you need to close the tap on the correct time. Next we move on to localization and mapping. So localization is finding out where my robot is. So you are sitting in a room, you are driving in a car, you are near that building, you are walking towards that shop. So all this is localization. You know where you are. Same thing you need to know about your robot. So where my robot is actually with respect to its surrounding. And mapping is what does the environment look like to my robot. So I can see the buildings, the road, the objects, but I don't know whether my robot is able to see. Obviously, I know my robot is not able to see, so I need to create a mental map or a simulated map of a 3D map of the surroundings in the robot's brain. So creating a map of environment and keeping a note of the robot's position in it is localization and mapping. And we need to keep updating the map and the robot's position as the robot moves in the environment. So this is what a robot map looks like in the mind of a robot. So it is using different kind of sensors, cameras, or lidars or sonars to map the environment. So we will move the robot in the complete environment once, and it will map, okay, there is a wall here, there is a door here, there is a table here, and it will store that in his memory. And next time we can perform navigation plans. Okay, go here, go there. So it will use that memory or that image from the map to understand, okay, like 10 steps from now there is a wall, 3 steps from now there is a door, and I need to take right after this and do that after the next step, right? So all these things are covered in human robot interaction, and we saw how what the history of we saw the how the robotics evolved from the history to the present, and what is the importance of human robot interaction, what are the different things which are used to have a successful human robot interaction. So with this I would like to end this discussion, and I'd like to thank you for your time. So thank you. We'll meet again. Take care, stay home, stay safe. Yeah, okay, I'm sorry. So there is one more topic left. So we have this Python gazebo and Python ROS and gazebo simulations. So what Python is a programming language to tell robots what to do and how to do. And so like any other language, C++, C sharp, or Java, I can use Python to program my robots, instruct my robots to do this and don't do that, right? And ROS is a robot operating system, a popular open source tool for robot integration and development. So I can use ROS to integrate all my sensors together, and create an environment in which, like, I have images from my camera, I have data from all other sensors, and I'm writing my algorithm in that, and I'm deploying it whenever there is a need. So ROS takes care of communication, visualization, perception, robot control, hardware drives, machine learning, data logging, simulation, computer vision, and motion planning, all in just one cell. It is being used for like 20 to 25 years, and there is a huge community which supports ROS, and there are a lot of open source libraries. You need not start from the scratch every time you want to program something. You can use the previously available libraries, and on the bottom left you can see a simulated gazebo simulation or an environment. So what gazebo is a virtual environment with real life physics where we can run different type of robot simulation without the need of having a physical robot. So so if you take a ball in your hand in the real world and drop it, the ball will go down and bounce back up, and after some time it will stop. So this is because there is gravity present in the real environment. And to test a robot in the real environment, what we used to do was like make a robot, perform all kind of testing, and like if it fails, make another robot and try the same, keep iterating until you get the best robot. But we this ROS in this new technology, we need not do all that. We have a gazebo, which is a physics engine which simulates all the physical laws in a virtual environment, and I can put a robot like this in a virtual environment which has a table, which has a sofa, which has a chair, and I can program it to drive in this room and make a map of and put different virtual sensors on it and test, okay, which algorithm is working fine, which algorithm is not working fine, right? So with this I think we have covered the history of robotics, what is the state of art of robotics, why it is important, and now so why we need human robot interaction, what is the importance of human robot interaction, what it takes to have a successful human robot interaction. So I would like to end this discussion here, and I would like to thank all of you for joining us, and take care, stay home, stay safe. Thank you very much.